Welcome to The Explainer. If you've ever felt your code just spiral into this tangled, chaotic mess, then this one's for you. Today, we're going to demystify object-oriented programming in Python. It's an amazing way to turn that chaos into some truly elegant and powerful structures.
I mean, you know the feeling, right? You start a project, and everything feels so clean, so simple. But as you keep adding features, it grows into this crazy web that's a nightmare to follow and even harder to fix. If that sounds familiar, trust me, you are not alone.
The great news is, there really is a better way to build your code. We're going to explore object-oriented programming, or OOP for short. It's a seriously powerful approach that helps you bring order, logic, and a solid structure back into that chaos. All right, so let's start with the absolute foundation of OOP. Classes and objects. To really wrap our heads around this, let's just imagine for a second that we're architects. So first things first, you need a plan. In the world of OOP, that plan is called a class. Now, it's really important to get this. A class isn't the building itself. Nope. It's the detailed architectural blueprint that describes what a house should have. Things like rooms, doors, and a color. So, once you've got that blueprint ready, then you can start building an actual physical house. In OOP, we call that house an object. It's the real, tangible thing that you create from the class, and it has its own specific properties. And here is where it all clicks. The class is the idea. The blueprint might just say there's a plan for num rooms, but the object, that's the reality. This specific house has exactly 3 rooms, and it's painted blue. You see? You can have one single blueprint and build a whole neighborhood of unique houses from it.
Okay, so we've got our blueprints down, but what happens when we want to build something pretty similar, but, a little different? This is where OOP gets really efficient with a concept called inheritance.
So you've designed a standard house. It's perfect, but now your client wants a mansion. Are you going to pull out a blank piece of paper and start all over again from scratch? No way! You take your existing plan and you just add to it. And that, right there, is inheritance. So here's our original house blueprint. It's got the basics covered, right? It has attributes like the number of rooms and a color, and it even has a method, like the ability to open_door. It's solid, it's functional, and it's totally ready to be reused. Now, with inheritance, our new mansion class automatically gets everything from the house class, like instantly. It inherits all the original stuff, and all we have to do is add the new special feature, like a pool. We've just reused our work and extended it. So simple, so powerful. And that's the crucial point. Inheritance is built on one of the most important principles in coding: don't repeat yourself. It lets you create this whole family tree of related classes, which makes your code incredibly efficient and so much easier to maintain in the long run. Okay, time for our third core concept, and this one is a lot of fun. It's called polymorphism. I know the name sounds super complex, but the idea itself is actually simple and incredibly powerful. It's all about making flexible, interchangeable parts. Let's stick with our construction analogy. Imagine you've got your team on site, a plumber, an electrician, and a painter. You can walk onto that site and give every single one of them the exact same command. All right, team, get to work. But are they all going to do the same thing? Of course not. The plumber starts fixing pipes, the electrician starts wiring the lights, and the painter starts painting the walls. And that right there, that is polymorphism. One single command, or in code, one method name, like doWorkout, can create completely different results depending on the object that hears it. The power here is just incredible. It lets you write this super flexible, generic code that can work with all sorts of different objects without ever needing to know their specific details. Your code can just trust that each object knows how to do its work. So, we've basically laid the foundation. Let's take a quick step back and just look at the powerful new toolkit you now have for building much better, much more organized code. So these are really the 3 pillars of OOP. You use classes to organize your code into these neat, logical blueprints. You use inheritance to reuse those blueprints and build on them without ever repeating yourself. And you use polymorphism to create flexible components that can all interact in these really powerful, adaptable ways. By mastering these concepts, you're not just writing lines of code anymore. You're becoming an architect, designing elegant and robust solutions to really complex problems. So I have to ask, what's the first blueprint you're going to build?